All right, so the average rate of change of any given function just describes something that you should be familiar with called slope. It's talking about whether or not in this particular area of a function or area of a graph, is this increasing or decreasing? How fast is it increasing or how fast is it decreasing? You are going to see average rate of change a lot this semester in Algebra 2. So please really work on this skill. It is not very difficult, but it'll show itself a lot, so it's very beneficial to you to be good at it now so you can use it the rest of the semester. And you'll probably use it in future classes, whether it's pre-calc or calculus, at some point in your math career as well. Average rate of change is interesting. I actually have used this personally when I was in my sports medicine degree working with athletes. If we were to, I don't know, time them doing something, especially running over a distance, we could show this time or show their speed graphically, and then finding out the average rate of change at the beginning part of, let's say they're sprinting 100 meters. So from meter 0 to meter 30, how fast were they going, and compare it to the second chunk of 60 to 100 and how fast they were going there, and then compare this average rate of change, and then this would help actual trainers, strength trainers, determine what was going on at that chunk versus what was going on in a later chunk, and then compare the two and see about whether it was form related, that they were slower during this time, or vice versa. Those types of things. So average rate of change shows itself a lot, and it can tell you a lot about what's happening over intervals of time. So average rate of change in this case, though, the biggest concept that I need you to take home with you is that it's just the change in function values over the change in x. F of b minus f of a over b minus a. Now, that's kind of a funky looking formula. All I really care about is the change in y's. So hopefully by now you remember that y is the output over the change in x's. X is the input. Another way to write this, and this is the one I really want you to hold on to, is y2 minus y1 over x2 minus x1. So again, the change means the difference between the second y value and the first y value over the second x value and the first x value. So change in outputs over change in inputs. You might hear it a lot of times said that way as well. The question that says, does this look familiar? Hopefully it does. Again, I mentioned the word slope. Please write slope down in here. Does anybody remember the formula for slope? It in fact is exactly what I wrote over here. And so their fancy thing of saying f of b minus f of a over b minus a, all that is saying is change in outputs over change in inputs, change in y values over change in x values. That's the concept there. So in order to put this into action, you need to reference this formula all the time. You'll see that again all semester long, so please make note of that formula. This is an easier way to remember it as well. Change in y's, that triangle just means change. Change in y's over change in x's. We're going to investigate a linear formula then. Going to the next page. Objective 1, determine the average rate of change of a linear function, or just a function itself. We'll call it linear because the highest power in this case of 2x minus 1 is just 1. It gives a graph here, but I want to do this algebraically. You're going to reference graphs later in this video. So if this is example 1, consider the function f of x equals 2x minus 1. Hopefully you can piece together what the actual function piece is, which is 2x minus 1. The input are the x values right here given to you. And the output is whatever f of x is going to equal when you put the input in. So when doing rate of change, you need to identify the four pieces. I'm going to write that formula again. y2 minus y1 over x2 minus x1. You need to identify 4 pieces, y2, y1, x2, x1. That's the hardest part about this. So if I was going to do example 1, I already know my x2 and my x1. They're given to me, 0 and 1. And you read it left to right like a book, and so in this case 0 comes before 1. So this is going to be x1, this is going to be x2. And I need to then find my y1 and my y2. And if you could hopefully predict now that x1 of 0, I need to put into my function 2x minus 1 to get y1. So that first part, I'm going to evaluate f of 0 to find my y2. Or I'm sorry, to find my y1, the partner of x1. F of 0 equals, remember, if you're doing functions, inputting something into a function, you need to identify first the place of parentheses that's going to take place of that x right here. And then I'm going to put in my first input, or my first x value there, and do the math. So f of 0 equals 2 times 0 is 0, minus 1 is a negative 1. So my first coordinate point, again, this is function notation here. I'm going to write it as a coordinate point, is 0, comma 1. Where this is x1, this is y1. y1 of 1, or negative 1, I'm so sorry, negative 1. That's my first output. Now to find my second output, I'll do right down here, f of, in this case, 1 now. This is if you're doing it algebraically, remember. And there will be times, especially on IXL later, where you're just doing it algebraically. In order to find, because again, algebraically, they're going to give you the inputs, but you need to put them into a function to get the outputs. That's what I'm doing right now. F of 1, so I just first write parentheses, and then input my next input, which is 1, and then do the math. So f of 1, second input, 2 times 1 is 2, minus 1 is just 1. So this is, again, function notation. I'm going to write up here my second piece of information. If I input 1 into that function, my output will also be 1 in this case. So I have now x2, and this is y2. So I have identified all 4 of my pieces of the average rate of change formula. And so now I can actually do that math to figure out, I'm not done, that's the only step, is to get to here, to figure out the actual average rate of change. So I'm going to take my y2, put it in place for y2, which is going to be 1 in this case, and I'll just make note that that was y2. And then I'm going to take 1 minus the y1, which in this case y1 is a negative 1. Please put negatives in parentheses so you know what you're working with here. And that's y1. And over my x2, which is, I've identified here, 1. And I'll just put x2 in parentheses just so you know what I'm referencing. And then minus my x1, which is right here, is 0. So if I do that math, and I'll label this as x1. If I do that math, on top I have a 1 minus a negative 1. Hopefully you'll be able to recognize that if you have 1 minus a negative, they turn to positive. So 1 minus a negative 1 becomes 2, becomes 1 plus 1. So I have 2 on the top. And in my denominator, 1 minus 0 is 1. So to simplify it then, 2 divided by 1 just simplifies to 2. That process might look different. You might get a fraction at times. You might get a negative number at times, but that's always describes the average rate of change from the interval of x equals 0 to x equals 1. So that tells me 2 things. It's positive, so because the number 2 is positive, I know that this graph is going up at a rate of 2. So you need to be able to identify if it's positive, it's going up, if it's negative, it's going down, and be able to tell me that as well. Go ahead and try to find on your own then the next one, the U try. Find the average rate of change of f of x equals 2x minus 1 from x equals negative 1. So the interval of negative 1 to 2. Go ahead and try that.